Hi everybody, it's good news. We are coming to method 4, the last method that we are going to use in geometry proof, and that is none other than the use of the tangent chord theorem, more popularly known as alternate segment theorem. Alright, as you know, in angle in alternate segment, the use of a tangent must be there with a triangle inscribed inside the circle. So very quickly, let's take a look at the question and do as per normal. Mark out any information that will be useful on the diagram before you begin. Alright, with that, please pause the video for 1 minute and do your necessary indication. Assuming you are done with your marking, I'm going to do mine now. Okay, for sure, PAQ is a tangent to the circle, and you can see two inscribed circle. I'm going to plug in whatever is going to be useful for me first. Alright, there is an angle subtended over here, DAQ. Alright, inscribed. The circle inside is ADC. So if you make use of angle in alternate segment, move along the same line, skip the first angle, this angle ACD will be equal to angle DAQ. Similarly, on the other side of the tangent line, we have another triangle, PAB. This angle over here, you can see in the triangle inscribed ABC, moving along the same line AB, skip the first angle, this second angle over here will be the same as well. PCA is equal to BAP. Now, there's also a pair of parallel lines. So let me indicate whatever I can do on my parallel line. Okay, BCA is equal to angle CAD. Reason being, alternate angles. And last but not least, please take note, there is a very useful cyclic chord. See if you need to make use of the cyclic chord later. So I'm going to just write down by the side. I may need to use my cyclic chord later. Okay, these are all useful information. So let us get started. So let me define this angle to be X. If you can see, alright, your job is to make sure angle CAD is also equal to X and is also highlighted in green. We know that it's X. Alright, but we need to put this in presentation. So in our sequence just now, step 1. Alright, let angle PAB is equal to X. Based on angle in alternate segment, angle BCA would be X. And please write down why. Because from angle PAB, this will also be equal to X based on angle in alternate segment. Alright, you should be comfortable with this reasoning. Last but not least, with the use of the parallel line, angle CAD will then be equal to angle BCA, and this is in turn equal to X because of the use of alternate angles. Last but not least, since all these angles are equal to X, therefore angle PAB must be equal to angle CAD. Alright, proven. There you have it. Now, let's move on to the second one. Alright, you need to prove that two triangles are actually similar. Alright, take note of these two triangles. You notice that there are two angles, they are the same. Alright, this is already equal to X. Okay, as proven in part 1. So what we need to do now is to make sure another angle is going to be the same. But based on observation, it's going to be tough. So what do I need to do? Alright, this is a unique case. So I'm going to make use of another denoted angle. See the sequence. Alright, I'm going to denote another useful angle. Why? Because I know that it's going to be a cyclic chord. Alright, I'm going to make use of the cyclic chord and get the angle from one figure to the other figure. So let me denote this angle to be Y. You can see clearly, in this case, this will be 180 minus Y. And the use of the opposite angles in the cyclic chord, I'll tell you that angle CDA will be equal to Y. And we have two angles, they are the same in the two respective triangles, and we are more or less done. So now, let us pen this in our working. First, in part 2. Alright, first thing, these two angles are the same. Alright, and that is shown in part 1. So I don't have to rewrite all my working all over again. Next, I need the other angle which I just defined. Let angle PBA be equal to y. So therefore, angle, let me take a look at my working again. CBA would then be equal to 180 minus y. Reason being angles on a straight line. Last but not least, you need to prove on the other side, for the other triangle, in this case will be angle CDA. Because the opposite angle in a cyclic chord will sum up to 180. In this case will be y. And what is the reason? Angles in opposite segment. And there you have it. We have two angles that are proven to be the same. And definitely, since in this case we have two angles to be the same as what we have done previously, this last angle and this last angle in the triangle will definitely be equal. Alright, based on sum of angles in a triangle. Therefore, angle BPA must be equal to DCA. Therefore, triangle CAD is similar, to triangle BAP, PAB. Okay, right in the exact same order. Reason, AAA, the use of the three sides being equal, or rather the three angles are being equal. Next, last but not least, you need to prove that. Notice, this is really familiar. Alright, it looks like a product of two sides is equal to product of the other two sides. And if you know this by well, you will have known that we are going to make use of the same corresponding side ratios being equal and choose the two pairs that are going to be the same to do your necessary cross multiplication. Alright, but if you're thinking of using these two triangles, okay, because I've already tried it in advance, you can't use it. Okay, but guess what? You will be able to use this triangle instead. Okay, what you need to do now is to just prove that these two triangles are going to be similar and use the same corresponding side ratio. Which are the two triangles? I'm going to highlight for you now. Okay, the triangles that you need to use will be this triangle as well as the bigger triangle. Alright, I'm going to outline the approach, but you write the reasoning yourself. As you can see, the shaded triangle in yellow has a common angle with this triangle in green. Similarly, based on angle in alternate segment, this angle is equal to this angle as well. And the last angle will definitely be equal because of sum of angles in a triangle. So what you need to do is just to prove triangle PAB is similar to triangle PCA. And make use of the same corresponding side ratio to do your last particular part.